Welcome, everybody, and thank you, Dr. Paul McKeever, for joining me today. I'm super excited to have this conversation with you.
Great to see you, Cherie. It's an honor to hold the Christopher Chiu Fellowship, and it does give me an opportunity to delve into things that can really make a difference. So it really should be said how important this award is.
Thank you so much. We're so proud to have you as our fellow. And I know that we've been talking about this project that you've been working on, and you can finally share some news with us. So, are you able to share more about the paper today?
I'd love to. So we've just released a preprint of our latest ALS research findings, and this is a significant step forward in our understanding of ALS and the complexities of this devastating disease.
So are you able to actually share like some of the high level findings with us right now? Because it is exciting to know, and we love that, there's these new findings coming, especially from you and the University of Toronto. So are you able to share some of the really high level findings with us?
Yeah, of course. So one of the exciting things is we've applied some really cutting edge technologies. And what we've done is using that identified different cells in the brains of ALS patients that are uniquely affected in disease and really unraveling sort of the cellular complexity of the disease itself. So within that, we did something really cool, which was we found out that the way in which the end tags on RNA molecules or genetic information are changed. And what this thing is called is alternative polyadenylation. So this is changed in different cells in the brain of ALS patients. So what we did is, this is super complicated. So what we did was we developed a new computer model called APANet, so Alternative Polyadenylation Network. And what this does is allow us to tie these little end tag events on RNA molecules back to the disease, but also consider within these tags what might be regulating these events. So this has never been done before. So this software is brand new and it has a broad level of applicability.
That is so cool. It's so crazy. I know that when we first talked about the findings of your paper, I was just mind blown. Like I think the intricacy and the detail is one thing, but then coming up with this whole new deep learning way of understanding findings and data was just totally incredible. And the fact that you guys like came up with it. You originated APANet, right?
Yeah, so working closely with this wonderfully talented doctoral student named Aidan Sababi from Gary Bader's lab, we developed this together, taking into account that we had produced data that is uniquely able to do this, to find this kind of thing. We just didn't have the software available to do that. And if you think about it, because there are thousands of these molecules in each cell, and most of them are showing changes like this. We couldn't possibly track this ourselves. We need something smart enough to respond to what we want it to do. So we asked a deep learning model to untangle all these things for us. So
Yeah.
the cool thing about that is these events don't just occur in ALS, they occur in other neurodegenerative diseases. So this could have really important ramifications for therapies.
So, your findings are so exciting. There's so much information, but I think what we really want to know is why are the findings that you found so important?
Right. So these findings are a step in the right direction, a big one, and it's because we're pinpointing basically the cellular molecular level events that are occurring. And with tools like APANet, that pinpointing is much more refined. So with that in mind, we can design new therapies that could target the disease. So I think that, like you said, the intricacies of it are being uh, grabbed from this really complex network more readily using this approach. And our hope is one day, um, you know, all the different things we're going to try now from that information is going to stop ALS in its tracks. So this is
That's
a
what we
unique
want to hear.
opportunity.
That's exactly what we want to hear in the ALS community. I mean, the whole like therapies and even just, you know, the ultimate goal is making ALS history, right? So, um that's exciting. So is there anything that you would like our listeners, our supporters, our friends, our donors to do? Anything to help you?
Yeah, actually, so one of the things is spreading the word about our research is incredibly helpful. Because awareness and support from donors is so important to allow us to continue this work. And especially in Canada, we really do rely on the generosity of donors. We're really fortunate to have people who are engaged in that regard. And we really couldn't do this without their help. So it is important to note that every contribution does make a difference towards finding effective treatments. So I do want to thank, existing and prospective people who are donating. Want to thank them for doing so because it's really valuable and it goes a long way.
Thanks, Paul. That's amazing. And we'll continue to share your information and your news also. So, as you know, we're going to publish this blog on social media and on our website, on our blog, which will be accompanied with a high level page about your paper with a link. So, for anyone who has a background in science, because I have tried to read it and I don't have a background in science. So if you have a background in science and you would like to, you can actually read the paper. We will link it. And we hope to see you soon. Dr. Paul McKeever, we've got lots of events this year, so hopefully we'll see you out in an event, and our listeners should come and say hello to you.
I'd love that. I do love conversations, so please do come up and chat. Uh, and thank you for putting this together, Sheree.
No problem. Thanks, everybody. And one day we hope we'll make ALS history.